Hi everyone, thanks for showing up after dinner. I was almost saying after lunch. So this talk is about Spark and Spark Declarative Pipelines. I also want to use it to give you some outlook of what is happening with Spark and pipelines. All right, so what I want to do is basically enable you to do something like this. This is literally something I built in less than half an hour. Like not the visualization, don't get it wrong, it looks nice, it looks pretty. Like a year ago, I spent a lot of time in visualizing this aircraft data, and even with the support of GPT, it took me many, many days to come up with cool graphics. But the graphics now, and I was kind of shocked, like with the last GPT announcement, it almost turned into hello world. You know, once you have the right data, it's like, give me a 3D visualization of all these planes of my data set. So the graphics is like AI, you can just do it, you can just generate it. And as so often, the magic is in the data. So I want to show you how you can get to the data, how you work with that data, how you create data pipelines, etc. And that whole project sounds like a lot, but at the end, it's like very, very little code, and it's something you can do in your next coffee break if you want. So this is how far this technology has got. So I'm Frank. I work for Databricks since half a decade now, which makes me feel old. Like I work in this intersection of products and engineering and yes, marketing, which means basically nobody's listening to me at the company because they all think like, oh, this is the guy from marketing and vice versa. Before that, I spent some time building up tech evangelism for AWS, did some other things, but you're not here because of me. I think you're here because of Apache Spark and the amazing things we can do with Spark. Now, if I think back, like when I looked into Spark the first time, like my background was in Java Enterprise. We had all this code, to get something tiny done. And then I saw these Spark things where you just have one line you read from a directory which contains a number of JSON files, and every JSON file contains a number of records. And you could just say now, give me all the customers that drive an Audi car, for example. And it was like 2 lines. I was like, oh my God, this is so powerful. And then if you do it in the right environment, you can, in one notebook, switch to another cell, and then you just start writing SQL. And if you feel more comfortable, you just do the same thing in SQL. And I'm super opportunistic. Like when I started to work at Databricks, I started with Python. And now I feel like, oh, come on, whatever I can write in SQL, I write in SQL. And the cool news is, even things where you think that's not the SQL task, like, read from a Kafka topic and ingest a data stream, we can now write in SQL. So it has advanced a lot. This is just the static case. There is like a number of files with a number of records, and we just read them. But then there's also this other thing, which is this automatic parallelization, which just happens in the background. So Spark distributes this in a cluster. It spins off, a number of tasks. They work in parallel concurrently and come up with a cool result. So it allows you to scale beyond a single box. It allows you to scale on a cluster, but you don't have to really do this distribution yourself. This just happens with a lot of optimizers and a lot of technology that went into this the last, 13, 15 years. Now, one more step is if you go from this static data to a data stream, and assuming some of you have been working with MQTT or Kafka or Kinesis, like I spent some time working with Kafka when I was at AWS and their Kafka managed service. And then I did a video, and then a lot of people sent me questions like, hey, Frank, can you teach us how we can write a Kafka client that just sends some data? I was like, well, you'll just read some data or send some data. It could be spark.read format, and then, just say, instead of this read format JSON, you replace it, and you say read stream, and then Kafka Kinesis or from some socket. So reading from a stream is as easy as reading static data. Which of course brings us to the next step. how is this if you see this from an enterprise perspective? So if you talk to the big, let's say, car companies, they say, yeah, we ingest a lot of data. We have these data pipelines. We have like thousands of different data sources, like what you see here on the left-hand side. And then, of course, we need to ingest data, operate on the data, transform the data, clean the data, make sure no bad data flows into our tables, and then feed those use cases, the downstream use cases that you see here. And the whole thing is what we call data engineering and data pipelines. And this is what this talk is about, to just give you some background. Now, the talk is also looking back at what happened the last 10 years and how can we improve on that. It's like an additional layer on top of Apache Spark, which is like a lot of people try to build them. Sometimes, I don't know why, but sometimes I get like people slacking me, messaging me on LinkedIn, hey, Frank, I'm trying to build this abstraction layer. What do you think? And I was like, first of all, why are you asking me? Second, I'm like, what problem is it that you're trying to solve? So I acknowledge there's a lot of people trying that. Then I also see like this Spark Declarative Pipelines used to be a product within Databricks, and then it got open sourced. So the question is, what qualifies Databricks to do that? And one of the answers is that the original creator of Spark Streaming, Michael Armbrust, is still working for Databricks. So he was the guy literally saying, I built Spark Streaming, and we had like, tens of thousands of customers in the last decade plus. Looking back at what we did, like how would I improve it today? So it basically goes back to the original creator, and then you can see what is the new layer on top. Okay, and the next question is why simplify? Isn't what we have not good enough? And the other question that we need to answer is like, what's the declarative in Spark Declarative Pipelines? So first of all, declarative. If you look at the bit of code, and I'm planning to torture you with a bit more code, sharing the slides, you don't need to take photos. So the plan is to torture you enough with the code that at the end, when I'm done with the code, you all say, well, I agree, it's really difficult, and I want to see an easier solution. That's the secret plan of this talk. Okay, so if we look at exactly this example that I gave you, we want to read from Kafka. So there's a Kafka broker out there, Bootstrap server topic. We want to read some values and want to do with them something like store them in a Delta table. It looks like this. And the thing is, it's all declarative, and the only thing, like when we kick this off, is this last line, this start line. But all the rest is where we just declare the system what we want to do. So it's kind of declarative already, and we have this declaration, which is huge, and then we kick it off, which is this execution step at the end. So kind of okay with this declarative. What's a data pipeline? Sounds like an easy question. No, it's something that produces and updates a set of data sets. So it kind of looks like this. We have these data sets. Something needs to produce them. It's classically a query. And then they have some order. So for some reason, especially the marketing people want to point out, show their tech skills and say that's a DAG, a directed acyclic graph. So there is some order of execution if we talk about such a pipeline. So it looks like this. And now the question is, why should we make these pipelines declarative? So that's my proposal here. We have to make them declarative. And the answer is because if not, if you would do this manually, and that's something looking back at what people used to do the last decade plus, it turned out to be rather difficult, like really difficult. And I want to kind of convince you about that, first of all. So I had this case where I said, look, Spark itself already is declarative. You declare what you want to do, and then you kick it off. What if we have more than this just one cell in a notebook where we read from a Kafka topic? What if we have, the world's most common data format, CSV from Excel? You need to read from that as well. And then you have two sources. What happens? You always want to join them. You join them into something, maybe you call it fact order. So you have CSV that needs to be read, Kafka stream that is read, and then you need to join it. Well, kind of what I told you applies. We kick it off here, and here, and here, like in 3 different locations. Now the thing is, if you do the same thing in 3 different locations, how would you run that? And now some of you might say, well, Frank, let's not overcomplicate it. Just put it in one file, execute this one first, and then this one, and then this one, which is okay. You can do that. But then think about these enterprise scale pipelines where there is more than 3, maybe there is like 100 steps or so. And then you realize the first 2, we execute them sequentially, but we could execute them in parallel. So we waste processing time, which, as you all know, is especially true in cloud times when it doesn't cost you more to run 2 things in parallel at the same time versus running the 2 things sequentially. It's like, assume like the first one is 1 compute hour and this is 1. So at the end, it doesn't really matter. And if you run them in parallel, you would just save time and not spend more money. So that's like a miss if we do it this way. Now, the answer is, well, there's multi-threading. Let's just define some threads, kick off those threads, and then it's running in parallel. Let's do it this way. So you're probably much better at this than I am, but we could start those threads, kick off these threads, and then we have like this extra code that looks like this. So we do the thread management, which also means if your pipeline changes, you need to change the thread management. And then for someone like me, I would be like, I don't really want to do that. Like, why do I have to do that? Is it really necessary? I care about the data and not managing these threads. So that's certainly something you don't want to do. And now the other question is, what if something goes wrong? Like, there are these kind of errors, like I would create them if I didn't have enough coffee in the morning before I start. So it's custom ID here, and then it's customer ID written somehow differently here. Or I would create them if the last coffee is too long away, like 1 o'clock at night, and then I would do the same thing. But this is something you want to catch before you even kick off the pipeline. What about other errors, like something, the Kafka goes away, like you have a network glitch, and then it actually is working, but it's not working in this second, so you need some retry at runtime. Well, the answer is you can code them, you can add those retries to your code, and then you have you have the multi-threading still, you have the retries, so your code is getting longer. And then there is this last thing of errors, kind of retries that you want to have. Assume your pipeline is working, kind of working, and then your boss comes and says, well, it all worked, but there's this one data set, and you need to re-execute that one query for that data set in the middle, I say naively. How do you do that? Well, you could code it, just like scan some command line arguments where you say retry this particular data set, and then you redo this data set in your code. But you see the whole tendency, like the whole torture I'm showing you here, is there's a lot of things that potentially could be done by the platform and shouldn't be done by the application developer. Okay, then sometimes folks say, okay, but then maybe I'll just add another layer, some orchestrator. Here's Airflow, but it could be any kind of orchestrator, which again means you start managing and programming and maintaining this DAG that probably you don't want to or don't have to. So it's a possibility, but it's probably also not what you want to do. And then it's the very last one. There's also other kind of issues because these streaming queries, they're asynchronous. So if you have a batch query like the CSV file and you want to do this every 15 minutes and you have this streaming query like reading from Kafka, you want to continuously do this. What could happen is that you kick this off, but nothing has happened here. And while you want to join that data, that table even doesn't exist yet because it was a asynchronous method. So there's a lot of complicated things, and you can code for that again. Just want to skip over that. And that was this first pipeline run problem. Right. So a lot of talking. Now, what if we applied the same principle where we declare what we want to do not only to one cell, to one statement, to one data set, but to the whole pipeline? And first build a plan and then execute this plan. And guys, this is Spark Declarative Pipelines, SDP sometimes. And it looks like this. This slide, I apologize, it could have been much easier. First of all, what you really need to know is there is like 3 or maybe even 2 components only that you should take away from this talk, like streaming tables and materialized views. So the easy thing to take away is a pipeline in SDP consists of these streaming tables and materialized views. There are also these temporary views that you can use in a pipeline. They're not persisted. They're more like a intermediary step that you do to simplify your pipeline, to break it down into logical pieces. And there's also something more low level, like a flow that connects a data source to a data set. But for the easy hello world getting started, what you should take away is it's streaming tables and materialized views. Okay, so if you have those 2 building blocks and you kind of put them in a pipeline, you can create your first Apache Spark declarative pipeline. The streaming table, and sometimes we abbreviate them as ST. It's not a terrible long word, but I don't know, sometimes it's done like this. They continuously update a table. So they do exactly once ingestion, and they append only. So if you want to read from, let's say, this directory with the JSON files, and someone is dropping more JSON files into this directory on an S3 bucket, which is continuously updated, that's such a situation. If you want to read from let's say from a Kafka topic, it's the same situation. It's reading, it's keeping state, it's appending. You can do these streaming operations, which are append only. But what you cannot do is update existing rows in that streaming table. That's not the right mechanism. So it's real-time incremental data ingestion, and that's it. Now you say, okay, but what if I have more complex aggregations? And then we have these materialized views, MVs, sometimes abbreviated. And they're kind of what you know from an MV in Oracle, it's like efficient aggregation. It's pre-computed, it's persisted, and it can be incrementally computed. So this incrementally computed is always a big discussion. The proportion of MVs that can be incrementally computed is increasing. So there's a whole team, at least at Databricks, working on this. Because obviously, imagine you have such an MV, let's say with 1 billion rows, and there's like 17 new rows added. You don't want to recompute 1 billion, 17 rows. Ideally, you just want to compute those 17 rows. And that's a hard problem. There's a lot of headroom to work on, and the percentage of these incremental computations is improving. If you look at the code, and I kind of skipped the previous one, it's a simple create streaming table, and then you can say select star from a stream. And for the materialized view, it's create materialized view, and then do any select and any aggregation. And that's it, more or less. You put those together, like streaming tables and materialized views. You wrap them in a pipeline. And then if you draw this in a pretty way, like my colleagues did, this is where I stole the slide. You typically have the streaming tables here on the left-hand side, and they read from some data source. Same here. And then you have some layer in the middle where you do your aggregation and your cleaning. And then you have very often a materialized view, which is kind of the gold table that you serve to the downstream applications. And then this is called like medallion architecture, like the medallions that you get at the Olympic Games. It doesn't have to be very rigid sometimes, Like a lot of tech demos that I do, I don't feel like I need 3 layers. But very often for the, enterprise-wide naming and architecture blueprints, it makes a lot of sense. Right. Now, if you do this on a Python level, you can do it as well. The thing is, actually, I need to correct this. Let me click forward here. Typically, it's imported as DP, like DP for declarative pipeline. And it's like from PySpark import pipelines as DP, and then it would be dp.table, and you have this name of the function, which is then also the name of the table. And then inside this, what you do is the same thing as you did before. In Spark streaming, you do your Spark read stream format Kafka. And the whole, this decorator, dp.table, turns it into a streaming table. And there's also one for materialized view. You see it here, materialized view, customers. The whole thing is, there is no DAG object. So the DAG is constructed by the way you arrange your code. And the way you arrange your code is obviously, like if you have this fact order here, it's reading from those previous streaming tables and materialized views. So it's kind of, concatenated together. And the DAG is implicit in the code. You don't have to specify it extra. And we can also visualize it. And then sometimes I remember when we did this the first time, someone told me, I don't like this approach. You draw your pipeline. I'm like, no, we never draw the pipeline. You write the pipeline in SQL code, and then we take the SQL code and visualize it as the DAG. So it's this way around. It's not the click, drag, and drop thing. Okay, so this is the whole thing, what you need to know about declarative pipelines. It could be Python, it could be SQL. You can mix and match. Like I told you, I'm very opportunistic. I'm old enough to forget things, and then I feel like, oh, no, I want to do this in SQL. It's much easier. And then, I don't feel comfortable. I want to do this in Python. Within one pipeline, you can use SQL and Python. I'm not saying you should do that. Maybe some teams, they literally focus on SQL only if you come more from an analytics background. Some other teams, they come more from an AI background. They focus on Python only, and some do just that stuff. There is a command line, so you can do this in PySpark. It's pipelines in it, and then you get a template folder that gives you a little template that you could then run. Now, the cool thing, and I should have put this probably in a big box or red letters. Now, SDP automatically handles all these problems I was torturing you with, where I showed you the code, like validation, pre-validation, dependencies, retries, parallelization, like executing this in a very optimized way. One and the same pipeline you can also run continuously, then it just keeps pulling from a S3 bucket or from a Kafka topic, or you can just schedule it and run it like the old batch thing that we did, like run it on a Friday afternoon at 2 o'clock. It's the same code, which is also kind of cool. Okay, now I can show you this. How's the timing? The timing is very good. I can show you actually a lot of stuff. Let's start here. No, hang on. I'll show you a bit more with. I show you what I show you first. This is always. I show you an example, which is actually this flights demo. Here you see the same graphics, which I have in two different ways. One is literally the pure PySpark VS Code. You just install the dependencies that you need, but there's nothing remotely related to any vendor. The other one is you go for a free, and free means forever free account. Like we have a free Lakehouse account at Databricks. I say forever free because it's not like AWS, where you have these free for 1 year with a limited quota. And then after 1 year, you need to start paying, or you forget, or you lose your credit card and you start a new free account. For this free account, you don't have to do it. It's free forever. There are some resource limitations, but the thing what I'm trying to explain here, the same example, you can run it one way or the other way, and it's the same source code, basically. So you can explore both if you want. I'm going to show you both as well. And for this example, remember you saw the globe, you saw all these planes on the globe. You need to get to the data. And to get to the data, there is an API. It's called OpenSky Network API. And what they do is they collect these signals from the planes, these ADS-B signals that the planes send. And it's basically, well, you can participate. Like a lot of people have these small antennas on their balcony. I bought one now. Like I live in the center of Munich. Like there's another house very close to my house. The apartment building is at my house. So the angle that I have, towards the sky is very limited, which means I only detect the planes that are flying super high in this angle. I'm not too far away from the airport, so I wish I could see a bit more. But a lot of volunteers do that. So it's a crowdsourced project. There's obviously other API providers that really resell you that data. So the OpenSky data is free if you're personal or if you do academic stuff. And so I talked to them, and they're like, okay, please show it. Like, you're okay. Even if you work for Databricks, technically, we let you show that. This is why I'm sharing this example. And the whole thing is, it's encapsulated in a data source. And that's the thing I want to show you in a second. And then remember what I told you, streaming tables, materialized views. I said streaming tables are great for ingesting data. This is what we do to get the data from OpenSky. And then we want to have some summary, some aggregation. This is what we do in a materialized view. Now, the data source looks like this. Remember the second, third slide I showed you when I said, isn't it cool that we can read from Kafka almost the same way as we can read a JSON file? And the only difference is the read stream instead of the read. And then I said from Kafka, you can read with read stream format Kafka. And now we can read this plane data from literally every plane right now flying in the air with format OpenSky. Now, of course, where does this OpenSky come from? It's one of these custom PySpark data sources. I kind of hacked it together and then we kind of open sourced it. So if you want to do this from Spark streaming, you can do it. If you want to do it from Spark Declarative Pipelines, you can do it. You can basically say spark.readstream format OpenSky, and then you have all this data that you need to create such a cool visualization. And this is what I wanted to explain. And now I switch back to VS Code, and it looks like this. So first of all, this is the streaming table. And guys, this is 3 lines. DB table, declarative pipelines, streaming table. The name of this method is also the name of the table. And then what I do is literally what I took from the slide, spark.readstream format OpenSky load. And that's it. And then here, technically, and that's the thing that kind of doubles the lines of code for this tiny example, we need to register and import the data source, of course. And then we need to have a Spark session. If you're not doing this within Databricks, in Databricks, you have this automatically, and you can just use Spark. And that's all the code. That's all the code to get to all these planes in the air. And then, well, 2 things. First of all, let's try and run it. That's, okay. That's Spark Pipelines. Pipelines run. See what it does. Now, I have to warn you, it's Spark, it's verbose. It's doing a lot of things. It's basically doing everything I was torturing you within the code when I said, this is a problem, this is a problem, this is a problem. So it's trying to see what's in there. It's queuing the things, it's executing them, it's starting them, it's running them, and then it's planning for the best execution. And then it said, well, this was it, it's done. Now I have another script. I'll show you the script in a second. It's this show results, which is always the thing where I get nervous. Okay. This is time ingest 1428. This is right now. So right now, from this custom data source API that we read from this streaming table, there's a flight with this call sign coming from the States, with this velocity, with this altitude, with this vertical rate, and there's 16 more columns. You get the direction, you get the height. There is the geo height. There is another height. There's vertical rate going up and down. So you can do all kind of crazy statistics. What are the country with the steepest descent rate, like the roller coaster planes and stuff. This is only showing the top, top 5 or top 6. And well, this is the whole thing. So now you have a table with all these planes. Currently, if you don't set anything else, I think the default is US, but you could set the region to Europe, and then you would see just the planes that are flying here. And then you have a second table, and you see the output already. It's kind of summarizing, number of events, number of unique aircrafts, what is the maximum ascent and descent rate that we have ever seen, etc. If I switch, this was the streaming table, written in Python, because I can, and then I switch to the materialized view, create materialized view, written in SQL, because I feel like this sounds like SQL. I want to type it in SQL, and that's it. So we have 2 files. This is all you need, which is a kind of a lie. You need 1 more file, because it's open source. What you need in open source, you always need a YAML file, and this is why we also have a YAML file. You need to give the whole thing a name. You need to tell it where to store the data. And then you need to tell it where are your transformation files. So they're under transformations, and every file under transformations. which is here, which is the SQL, and the Python file is part of the pipeline. And then you run the pipeline, Spark does the magic, and that's basically the very short version. Now, what we also can do if you decide, I mean, it's the typical game, you know, I'm not trying to sell you anything, but if you say, how would it look like as a managed service, you know, then what we can do is you get such a free account, and let me see. Yeah, it looks like this. Same file, ingest flights, return Spark, read stream, format OpenSky. First of all, what we can do now is take the transformations and recreate this DAG file. 10 minutes, that sounds good, thank you. And you see ingest flights, that is a streaming table, that's a materialized view. Here there is like 3,500 records ingested, and then this is a different, it's a different aggregation. I do it per country. What I can do is oops, the computer's not running because I was talking too long. Let's restart this. It's a different aggregation, so I look at the number of flights per country. Let's see if we can find it. It's here. So you can basically do your transformations here. You can also build your medallion architecture. You could say like, you know, give me a new, create a new folder, and then I have a folder which is like the bronze folder, and then I start with the silver folder, etc. And then you can rearrange your, you know, your things here. And you see, oops, I was showing the right thing. Let's sort here the other way. So most planes are from the United States. Second most is Canada. So this is sorted by country. And I mean, the advantage is then you have your runtime. There is a serverless runtime. You don't need to configure. You don't need to think about a cluster. You have this UI built in. And the other thing is you also have the governance built in. Basically, every table here, if we go back to the graph here, like every table here, back to the graph, and then view in catalog. There's this thing called Unity Catalog. It's another project that we open sourced, which is, by the way, the project where I always thought, like, you know, very often the saying is for Databricks, well, first of all, we're not here to build as many open source projects as possible. Some other companies have this, you know, this goal to, you know, create as much open source as possible. For Databricks, it's typically the other way around. We want to serve customers, and then often the question is not, do we open source it, but when do we open source it? Now, for Unity Catalog, the governance system, I was always like, nah, this is not happening, because this is like everywhere in Databricks, you know. This is so complicated to build this. How could you possibly open source it? We've done it. So it's available as open source. The cool thing is it gives you governance for everything, for ML models, for SQL tables, for unstructured files. You can have volumes and put them through UC. And what you see here is the UC level. So we have these tables in this UC catalog, which is super cool. And then you can also see lineage on a UC level where you could see, you know, the volumes where you read from them, and AI models that read from these gold tables. There is 2 more things I want to show you. One, I just want to kick off, but not wait for the final result, which is, if you say now, well, I think I get it. We need a pipeline, we need streaming tables, materialized views. I could possibly do that, and then we can start with SDP in our company. The good news, and depending on how you see it, and also the bad news is, AI is so good you don't have to do this these days. So what I can do is, and this is also why I was talking about Unity Catalog, if you look here, there's some sample data, and there's this bakehouse data set, something I built with my team like 2 years ago for our summit. And there's data like samples, bakehouse. We built like a global bakery chain, and there's like sales transactions. So what you could do now, today, is you click on New, and then, hang on, I don't even need to click here. I can click here. No, let's do it this way. New ETL pipeline. And then I say create with, that's the AI system, it's called Genie. And this is more like a UI problem. And then you can say create a SDP pipeline analyzing data from samples. What was it? Bakehouse dot, and then I think it's sales transactions. And then what you will see is it does everything I was just talking about the last 15 minutes. It's creating this medallion architecture. It's creating streaming tables for ingestion. It's doing a join. Probably you need to feed it more like what it's supposed to join. It's creating those goal tables that you can use down. Did I click here? Okay. It's cooler if I kick it off. But the frightening thing is it's very, very good. You know, what you hear from marketing, like this is where, you know, like where there's like all the knowledge from, you know, dozens of engineers put into a skill. This is true. This is literally true. So this is as good as I am. I'm not saying you should blindly trust it. I'm saying you should use this as a tool. Same way as you use Claude Code to generate code and then review it. And look here, it says, look, I propose bronze, silver, gold. Do you want this or do you want something different? So I'm happy, you know, like we could go this way. Okay, so this is basically what I wanted to show you. I have one more thing and then I'll take some questions. Not related to SDP, but related to this avionics example where we have, you know, these updates from the planes and they send like signals typically once per second or even more than once per second. The data source is getting them once per second if we want. So it's kind of real-time-ish, but not really real-time in a sense of you know, ABS from the car. It's not like milliseconds. What Spark can do now is real-time mode. It can do it since like a year. And what is coming is now the SDP, the Spark Declarative Pipelines. They can also do real-time mode. And that means for the people who used to do Spark, for the second latencies and the batch processing, but then also had Flink installed for the sub-second latencies, they all stay within Spark now and do Spark with real-time mode. Now, it's easy to imagine these flight examples. If I switch it to real-time mode, you wouldn't see a big difference. And you probably say, I mean, the biggest how to say, the harshest critique you might have now is, hey, Frank, but your example was like 3 lines and it was a hello world example. And I would argue, well, but it's super cool. You know, you see all these planes flying in the air. I want to show you something that our solution architects did. And they basically took the same idea and they literally slacked me and said, hey, you built this tiny example. We loved it. We built the real thing. It looks like this. So they built a commercial airline tracker, which is like this, and it's actually, so if I zoom in, you see these planes moving, like, you see? Well, they're not, even on that scale, they're not moving that far. And it's something they brought to Schiphol Airport, they brought to the Port of Rotterdam, and they, don't quote me, is that recorded? And they brought to the biggest defense organization that we have in Europe, as a POC, so they're talking to these companies. And this is literally, if you think about what is more latency critical than air traffic control. So this is what they build for these, you know, organizations and enterprises on a higher level. And the cool thing, it's a stream, it's a data stream, and these alerts are computed on the data stream. They're then written to Lakebase, which is a super fast Postgres database, and the whole UI is abstracted away from that. So it's reading from these Lakebase tables, from the alerts, from the positions, and from these zone aggregations. Now I stop. You get the slides. There is the link for the free edition if you want to try that. If you have any questions, talk to me. I'm on LinkedIn. I try to be friendly. We're prepping now for this big event that we have every year. So I'm a bit stressed, but like, please text me if you have questions. If you have any question now, I'm still here.
Yes, we can have maybe one question.
Please.
In the room. Okay, otherwise, just one question.
Hello, I have a question. Are there any benefits for using it for batch processing as well? I understood it's basically has a lot of benefits for streaming.
I think it's both. I mean, from my perspective, the cool thing is you write the code once and then you decide, do you want to run that file, that pipeline continuously, and it keeps pulling, and then of course you spend the compute, like it costs you more. And the other thing is, like, once you have that file, you can decide, well, I just trigger it like once per hour. So it works both ways. I think the real benefit is you have one way of writing that, and then you decide if it should run continuously or not. But like a lot of people use that technology and just do batch. Like what I said, like every Friday, 2:00. And they like this abstraction. So the classic question I get is, should we stay? I mean, honestly, you can do the same thing with Spark streaming. Like that's what people did for 10 years. And if you're a really good data engineer, you can do it anytime, But the entry level is much higher, You think about checkpointing. You literally think about what do you put where in your notebooks? How do you schedule them? So the entry level is much higher. And this SDP, I think, is a nicer abstraction. So if you kind of newish in that area and you want to start with pipelines, I would go this way. Any other short question?
Okay.
Well, if not, I hope you liked it. Thank you for being here.
Thank you, Frank.
Thank you.